Let's do chapter 17, problem 4. So the page that we're on is page 478. Number 4. And a reading of the problem. A quasar spectrum. Now a quasar is an extremely brilliant, extremely small, usually extremely very far away object. It has the luminosity of our entire galaxy, but it has a size that is about the size of our solar system. So it's a very concentrated source of luminosity. They're extremely brilliant. A quasar spectrum shows a shift in its spectral lines, delta lambda over lambda, of 0.158. Use the Doppler shift formula to determine what recession velocity this shift indicates, and then use the Hubble law to determine the distance to the quasar in megaparsecs, if h is given as 70. And be sure to calculate the recession velocity in kilometers per second. So we know that the Doppler formula is that V over C is equal to delta lambda over lambda. Now delta lambda over lambda in this problem is actually given to you, 0.158. Now the speed of light c is equal to 3 times 10 to the 8th meters a second. And if we want that in kilometers per second, as we need to have to use the Hubble constant, then that's 3 times 10 to the 5th kilometers per second. So the velocity that we're looking for is over 3 times 10 to the 5th, and that is equal to 0.158. So if we multiply both sides of the equation by 3 times 10 to the 5th, on this side they cancel out, and on this side we get 3 times 10 to the 5th. So that the velocity is equal to 3 times 0.158 times 10 to the 5th. And 3 times 0.158 is about 46.47, times 10 to the 5th. And we move that 2 decimal points, and we're going to get 46 times 10 to the 3rd. Well, let's move it 3 decimal points, 460 times 10 squared. So this is now in kilometers per second. And now we go to the Hubble law, which says that the velocity of recession is equal to the Hubble constant times the distance. And the velocity of recession must be in kilometers per second, as we now have it. And the distance is then given in kiloparsecs. So that tells us that the distance is equal to the velocity over the Hubble constant, and the velocity we now have as 460 times 10 squared. And we're going to divide that by the Hubble constant of 70 to get our distance. And 70 goes into 460 about 5.1 times. So that's 10 squared is our distance. And that tells us that 510 megaparsecs is the distance to this quasar. Quite far away, and they are very bright and very far away in the usual case.